Assalamu alaikum everyone. Today we will be solving May June 2019 paper 1-2 for chemistry O level. Question number 1. The diagrams show 4 different methods of collecting gases. Which method is suitable for collecting a gas which has the properties described? So basically in this question the examiner will give us a method and then he will tell us that we are trying to collect a certain type of a gas through this and the properties of that gas have been given. Before starting this question, we must know that all 4 of these methods have some sort of restrictions. The first one is called the downward delivery of a gas with the upward displacement of air, and this is used for gases which are denser than air because denser things tend to sink while less dense tend to rise up. The second method is a gas syringe, and an important point to note here is that it can be used for all gases provided that it has enough capacity to collect the volume of the gas you're trying to collect. And the third method is displacement over water, and the third method is displacement over water, and this can be used for gases which are insoluble in water. The fourth method is basically the upward delivery of a gas or downward displacement of air and can be used for gases which are less dense than air. So now let's dive into the options. Option A, method for collecting gases. 1, properties of a gas less dense than air and soluble in water. Well, it's used for gases which are denser, not less dense, so that makes it wrong. Option 2, denser than air and soluble in water. As I said that the gas syringe can be used for all gases, this option actually looks good, but let's explore 3 and 4 before. So third option, less dense than air and soluble in water. Note, soluble in water. And we said we can use this method only for insoluble gases. So C is wrong. D, denser than air and insoluble in water. Wrong. Why? Well, because it can't be denser than air, it has to be less dense. So the answer to this question will be B. Let's move to question number 2. After acidification with dilute nitric acid, a colorless solution of X reacts with aqueous silver nitrate to give a white precipitate. Remember that whenever you see dilute nitric acid and aqueous silver nitrate together being used to test for something, it is always a halogen test that is being done. So this means my main concern right now is the halogen, not the cation. It says to give a white precipitate and it was a colorless solution. So you should know that iodide gives a yellow precipitate whereas chloride ions give a white precipitate, and just to add it here, bromide give cream precipitates. So therefore it is either B or D. So what's the hint now? Well, the hint is colorless solution. I hope you guys know that sodium forms colorless solutions in aqueous form, whereas copper 2 plus in aqueous gives a blue solution. You should know this because you should have memorized the cation tests that are included in your syllabus by memory. Let me repeat that, by memory you should know them. So copper 2 plus aqueous is blue, so B is wrong, so the answer is D. Okay, question number 3. The diagram represents a chromatogram of the colorless acids present in a drink. Colorless acids. The chromatogram has been treated with a locating agent. Just to add it here, a very famous example within the syllabus is of that of ninhydrin. Amino acids by nature are colorless, and therefore, when we use them in chromatography, their spot and mixtures, we use ninhydrin to make them colorful so that we can locate them on the paper and then calculate the RF value. So they're basically asking us which acids are present in the drink. So the only way to find that out is to calculate the RF value for the first, second and third spot and then compare it with those present in the table. Remember, RF value is a characteristic of a certain compound. How do we calculate RF values? I hope you are aware. RF values are calculated by distance traveled by component divided by distance traveled by solvent. अच्छा, तो इसको I can call this as A, I can call this as B. So what's A and what's B here? Well, B is always the distance between the pencil line and the solvent front. इसको हम solvent front कहते हैं. This is called the solvent front, the height to which the solvent rises. So this is our B, and always remember, you take the distance from the what has been mentioned as the origin here, or in other words the pencil line, never from the base of the paper. So this is B. What is A? Well, for example, if I want to calculate the RF value of the spot 3, then A will be this. So what you will do is you will use a ruler, calculate A, calculate B, put it over in this formula and find the RF value for 3. And then you will compare it with these table values, and whichever one is closest to your value, that means this compound is present, or this perhaps the acid is present in the drink, and the answer will turn out to be B. Let's move on. Question number 4. Which gas will diffuse at the fastest rate at the same temperature and pressure? And we're talking about diffusion at the fastest rate and the same temperature and pressure. Well, two factors affect the rate of diffusion according to your syllabus, and they are, well, diffusion is directly proportional to temperature. That means if you increase the temperature, the diffusion rate for a certain gas will also increase. Other than that, diffusion is inversely proportional to the MR. What does this mean? It means the more heavy the gas is, the slower will be its diffusion, and that kind of makes sense, right? It's easier to make something that is heavy, make something that is what should I call it? Something that weighs less, right? If something weighs less, it's easier to make it move rather than something that is more heavy. So this means that because the temperature and the pressure have been set same for all these gases, I'm not looking at this factor, I'm looking at the AR/MR. Okay, so let's find the ARs and the MRs. Well, for argon, that's 40. For C3H8, it's going to be 12 into 3 plus 8, that makes it 44. CO2, 12 plus 32, that makes it 44. F2, well, I hope you don't make a blunder of calculating just the AR of fluorine and forget to multiply by 2, because this is F2 and that pretty commonly happens. So be aware of that. So I can see that the lowest MR is that of fluorine, and therefore the answer will be fluorine, because lower the MR, the faster the rate of diffusion. Okay, let's move to the next question. Two particles K plus, well, that's basically potassium, ion of potassium, and argon can be written as this and this. Which statements about these particles is correct? Well, the way that I like to solve these questions is to prep a bit beforehand. And how do I do that? Well, I'm going to write these down again. And I'm going to mention the neutron, proton, and electron. Well, I hope you guys know that the proton number never, like the number of protons in a certain element never change. In no matter what atom of that element we're discussing, the proton number is like a characteristic. A quick example, a quick analogy is, for example, if you live in a certain country, you are given this CNIC, and in that CNIC you are given this citizenship number, right? It's a CNIC number, so it's unique for you. Your CNIC number cannot overlap with someone else's. It's unique. If you change the CNIC number, you will practically change the person that you're looking for. Just as that, for atoms, the proton number is just like the CNIC number. It's the identity, a characteristic, a unique property for those elements. You can't change it. If you change it, you're now talking about another element. For example, if I talk about potassium, if I add one more proton in potassium, I'm now talking about calcium, not potassium, right? So be very careful that no matter what happens to an atom, the proton number is never changing. So this becomes 19, this becomes 18. How to find the neutron number? Well, all you have to do is subtract the nucleon number and the proton number. So this is going to be 39 minus 19, that makes it 20, and this will be 40 minus 18, which makes it 22. The number of electrons, well, for argon it's 18 because atoms are electrically neutral. I hope you guys know that. For potassium, it has a positive charge, which means it has one extra proton than electron. And because the proton number is fixed, how can I possibly have one extra proton in the atom? That's as if the electron is one less. So the number of electrons are 18. So option A, argon has more neutrons than potassium. Well, let's see, argon has 22 and potassium has 20. So A is kind of correct, but let's just look at the other options. B, K has more nucleons, that means protons and neutrons, than Ar. Well, potassium has 39 and argon has 40, so that's wrong. K plus has 20 electrons. Well, this is 19, this is 18, so and if you look at the electrons, it's 18, 18. So wrong. Potassium has a greater mass than Ar, does it? 39, 40? No. So the answer is A. Moving on. Question number 6. A mineral deposit is found to contain small grains made entirely of the element carbon, which means there's no other element present. Which property will definitely be true of the grains of carbon? So I'm looking at this sample of carbon and I have to be sure that this certain property will be there. How will I solve this? Well, for me, I will dive into the syllabus and look for something that can aid me here. We have studied two allotropes, diamond and graphite. So if I have to be definitely sure that this property will be present in this third form of carbon, then this property must be true for both diamond and graphite. And notice how I'm saying both diamond and graphite and not or diamond or graphite. Okay, so it has to be true for both. So let's look at option A. They will be made of atoms arranged in layers. Well, do you know how diamond and graphite look like? If not, then look here. Diamond is a continuous tetrahedral structure. It goes on like this, continuous. Whereas graphite are these hexagonal layers that have weak intermolecular forces of attraction between them. Over here, there are van der Waals forces. So now looking at these, can you tell me if this is option A is true for both? Well, the answer is no. It's true for graphite, but it's not true for diamond. So answer A can't be the correct answer. B, they will be soft. Well, diamond is in fact one of the hardest materials on earth. We use it for cutting purposes. And even if you have seen diamond in real life, you would have been sure it can't be anything soft. But graphite is soft, and therefore B is incorrect. C, they will burn to give carbon dioxide. Now that's something, if I don't have a lot of knowledge in chemistry, I would be unsure of. So let's look at option D. They will conduct electricity. Well, does diamond conduct electricity? The answer is no, because diamond does not have delocalized or mobile electrons, whereas graphite does, so it does conduct electricity, but in a unidirectional matter. वो तो फिर एक और ही story है. So the answer is C. I solved this with the elimination method, but we should know the reason why. Why is C correct? The answer is anything that has carbon in it, when you burn it, by burning it means you are burning it in air, so it comes into contact with oxygen, and when it comes into contact with oxygen, it reacts, in other words oxidizes, and gives carbon dioxide. This is also known as combustion. Okay, so remember, anything that has carbon in it, when burned in air, if there's sufficient oxygen, will give carbon dioxide. So 6 is C. Moving on. Question number 7. Which diagram shows the outer electron arrangement in calcium fluoride? Well, here you should ask yourself, is calcium fluoride a covalent compound or an ionic compound? I believe your answer would be ionic. So it can't be option A or option B, because in ionic there is a transfer of electrons, not sharing of pairs of electrons, which we see in A and B. Let's look at C and D. Well, we know that in ionic bond, It's a force of attraction between a cation and an anion. For O levels, we say it's formed between a metal and a non-metal, and the electron transfer is always from the metal to the non-metal and never the opposite way. So let's look at option C. I have fluoride ion, correct formula, calcium 2 plus, correct formula, fluoride ions, correct formula, and I see that this cation has lost 2 electrons, has donated them to fluorine to make it fluoride. So this kind of seems correct. Let's look at D. Fluoride, correct formula, calcium 2 negative. That doesn't really make sense to me. So can it be possible that these 3 negative charge, three negative particles attract each other? Well, no, they will most certainly repel, because we know unlike charges repel, and we define an ionic bond as the strong electrostatic force of attraction between oppositely charged ions. So these are all the same charges, so D is incorrect. The answer will be C. This was kind of an easy question, by the way. Question number 8. How many shared pairs of electrons are there in one carbon dioxide molecule? For these kind of questions, I really prefer making the molecule first. So there's C, carbon, oxygen, oxygen. Carbon is in 4th group, wants to bond 4 electrons. And then there's oxygen. Oxygen is group 6. It bonds 2 of its electrons with carbon, and the remaining 4 bond with each other, forming 2 pairs. So this is what carbon dioxide looks like. So the examiner says how many shared pairs of electrons are there in one carbon dioxide molecule. So we're talking about shared pairs of electrons. Sorry, I forgot to make the electrons here. Okay, shared pairs of electrons. So this is a shared pair, a shared pair, a shared pair, a shared pair. So there are 4 shared pairs of electrons. So the answer is B. If you overlook the word shared and you just, if you just read it in a flow like how many pairs of electrons are there, then you would have been like 1, 2, 3, 4, 5, 6, 7, 8, and your answer would have been incorrect. Or if you overlook the word pairs, then again your answer would be incorrect. So do give each MCQ a good reading before solving it. Let's move to the next question. Question number 9. 2 statements about metals are given. Metals contain a lattice of negative ions in a sea of electrons. The electrical conductivity of metals is related to the mobility of the electrons in the structure. In the exam, the time is limited, so you might be rushing through MCQs, and you just might, overlook the word negative. Metals do contain a lattice. Metals do contain a lattice of ions. Metals do contain a lattice of ions in a sea of electrons. But those ions are positive, not negative. So that makes statement 1 incorrect. Statement 2 is perhaps, it sounds good and it is correct, because electrical conductivity does depend upon the number of mobile ions or electrons and how mobile they are. So option A, both statements are correct, wrong, both statements are correct, wrong. Statement 1 is correct, nope. Statement 2 is correct, yes. Statement 2 is correct and statement 1 is incorrect. Let's move to the next question. Powdered calcium carbonate reacts with dilute hydrochloric acid to produce calcium chloride, water, and carbon dioxide. What is the correct ionic equation, including state symbols? I would spend some time on this MCQ so that the entire concept of ionic equation becomes extremely clear for all the students who are watching this. So, alright, so the first option is called the molecular equation. In the molecular equation, we show all, the complete formulas and how the reaction happens overall. We don't eliminate things, we show everything, completely. But the benefit of an ionic equation as compared to a molecular equation is that in an ionic equation, you first of all show the ionic nature of different compounds, because you will dissociate those compounds that are ionic in nature and can dissolve in water. And secondly, through an ionic equation, you will show the exact, let me repeat that, the exact reaction that is occurring in the reaction mixture, because many at times and mostly there are reactions where you have these ions that are present in the reaction mixture but are not participating in the reaction. We call these spectator ions. So the ionic equation will help you see the exact reaction. So let's get started with the steps for the ionic equation. Step number 1 should be make the molecular equation with state symbols. So it's calcium carbonate plus hydrochloric acid reacting, giving us calcium chloride and water and carbon dioxide. So this is my molecular equation. The second step is to give it state symbols. Calcium carbonate is solid. Why? Powdered. Powdered means crushed, solid. We crush it so that we can improve the surface area, so it's a solid. HCl is dilute. Dilute means there's a lot of water. So its HCl will have a state symbol of aqueous, because anything that is in water is called aqueous. Calcium chloride, I'm going to come to that later. So I'm going to come to calcium chloride later on. Water is liquid and carbon dioxide is a gas. Now to decide the state symbol of calcium chloride, that wasn't given to me by the examiner. You first need to refer to the solubility table that you should have memorized for your course while you were doing, let's say, experimental chemistry. So the state symbol for calcium chloride will be judged according to the solubility table. I'll just mention it here so that you guys could look. All halides, chloride, iodide, bromide. Well, I'm talking about these three for now. These are the three that we commonly discuss. Chloride, iodide, and bromide, whenever they are present in a compound, the compound is soluble. Except when they bond with lead, mercury, or when they bond with silver. Except for these three, whenever a halide, a chloride, iodide, and bromide will be present in a compound, that compound will be soluble if you provide it with water. So calcium chloride will be aqueous if you provide it with an aqueous solution. Where will that aqueous solution come from? Well, that's already present. There's a dilute hydrochloric acid. So when calcium chloride is formed, an aqueous solution is already present, so calcium chloride will dissolve. This will become aqueous. I hope that made sense, giving these their state symbols. So that's the second step. The third step is to balance that molecular equation. So one calcium, one carbon, 3 oxygen, 1 hydrogen, 2 hydrogen. So I need to write 2 here. This will automatically balance the rest. 2 chlorine, sounds good to me. So balancing is the third step. The fourth step is to dissociate anything that is aqueous and leave solid, liquid, gas unchanged. So the fourth step will be to write the solid, liquid, gas as they are, but dissociate the aqueous ones. Aqueous, calcium 2 plus, aqueous, plus 2 chloride, aqueous, plus H2O, which is a liquid, and CO2, which is a gas. So once you're done with the fourth step, the fifth step is to cancel out those things that are same on either side. These things will always have the same charge, the same formula, the same molar ratio, so and perhaps the same state symbol. So this gets cancelled out with this, right, because they're same on either side. What you are left with is the final ionic equation. Let me write it at the top. So it's calcium carbonate, solid, 2 H positive ions, aqueous, giving us what? Giving us calcium 2 plus aqueous plus H2O liquid plus CO. What happened to my oopsies? Okay, so let's see which option corresponds to this one. It's not this, not this, not this. The answer is D. I hope ionic equations are now clear to you. If you follow all of these steps, each ionic equation forming one will become a piece of a cake. Let's go to the next question. Okay, which mass of carbon contains the same number of ions as 16 grams of sulfur? Okay, so I guess another way to say this is, when I talk about the same number of atoms, can I say I'm talking about the same number of moles? Let me give you an example. If I have a dozen eggs, I say I have 12 eggs. If I say I have half a dozen eggs, I say I have 6 eggs, right? And if I say, no, I don't say there are 6 eggs. Instead, I say there's a half a dozen eggs. And then I say I also have half a dozen of bananas. Even if I'm not clearly stating the number of eggs or bananas, but the term half dozen gives me the clue that I'm talking about 6 each. Same is with moles in the number of atoms. When two things are the same moles, they do in fact have the same number of atoms. So first of all, know that moles equals to same number of atoms. You should know that. So let's first calculate the N for sulfur. That's my way of writing in moles for sulfur. So that's 16 sulfur is 32. So this gives me 0.5. For carbon, well, for carbon, my moles should be 0.5 because that's the question after all. We need to keep the moles / the number of atoms same. 5 is equal to mass over AR. So I'm interested in the mass, and the AR for carbon is 12. So the mass turns out to be 6 grams. So the answer is B. I hope that made sense. Let's move on. Question number 12. 3 dm cube of sulfur dioxide is reacted with 2 dm cube of oxygen. Assuming the reaction goes to completion and that all gases are at room temperature and pressure, which volume of sulfur trioxide is formed? There's a very easy way to solve this question. If you don't know it, then you might be confused that I have been given the volumes. How can I possibly solve this question? I can't find the moles because I don't have the concentration. So how do you go about such a question? The simple thing to note down here is, whenever in a certain reaction you have all gases, okay, all gases, all the reactants are a gas, all products are a gases actually, and the reaction is happening at room temperature and pressure, the rule is you can refer to the volume as the moles. So if all the reactants or products are a gas, and if it is happening at room temperature and pressure, then you can consider the volume as the moles, 3, and I can say this is 2. So now I'm interested in the value for sulfur trioxide. Whenever you solve a question for moles, you first need to be sure of within the reactants what is in excess and what is the limiting factor, because the limiting factor will always determine the amount of product formed. It will determine in how the reaction proceeds. So the first thing should be to identify that, the limiting factor. So I have 2 sulfur dioxide reacting with oxygen, giving us 2 sulfur trioxide. I will worry about that later. Right now, finding out the limiting and the excess. So I have 3, let's say, moles of this, 2 moles of this. Now let's forget about these and see that the ratio between sulfur dioxide and oxygen is 2:1. So this means if I have 1 mole of oxygen, I should have 2 moles of sulfur dioxide. So now let's say I have 2 moles of oxygen. How many moles of sulfur dioxide would be required for this reaction? Well, the answer turns out to be 4. Do I have 4? Do I have 4 number of molecules of sulfur dioxide? No, I don't. I have 3. So I have less than I required. So this means this is the limiting factor and this is in excess. Let's do it the other way. Again, 2:1. I had 2 sulfur dioxide molecules and 1 oxygen molecule. So let's say I have been given 3 molecules of sulfur dioxide. how many molecules of oxygen do I require? Let's cross multiply. The answer is 3 over 2, that's 1.5. How many moles or molecules do I actually have? 2. So do I have less than required or more than required? This was the required, this was the required, and this was present. So the present is greater than required. So this means oxygen is in excess. So does that make sense? Okay, so the limiting factor is sulfur dioxide. I know that for sure. This will determine the amount of sulfur trioxide formed. So if this is 3 and this is in 2:2, right? 2:2, ये sulfur dioxide है और ये sulfur trioxide है. So they are present in 2:2. That means 2 moles of sulfur dioxide react, 2 moles of sulfur trioxide formed. I have 3 moles. How many moles of sulfur trioxide do I form? Well, the answer is quite simple. It's going to be 3 because they're in 1:1, but well, fair. So this makes it 3 moles. And we assumed right in the beginning that we are considering the volume as the moles. Now I will consider the moles as the volume. So the answer is 3 dm3. Let's go on. Question 13. A sample of magnesium hydroxide MgOH2 is made by adding an excess of aqueous sodium hydroxide to an aqueous solution containing 1.2 grams magnesium sulfate. The mass of magnesium hydroxide formed is 0.26 grams. What is the percentage yield? The formula for percentage yield is it's actually the actual yield divided by the theoretical yield. The theoretical yield is what we are expecting when we do the calculations. The value that you get from the calculations, that's the theoretical yield. The actual yield is what you get for real. So the actual yield has been given to you, that the mass, that's 0.26 grams. I need to find what was I expecting, what mass of magnesium hydroxide was I expecting to be formed according to the data I have. So in theory, how much mass of magnesium hydroxide was to be formed? First of all, let's form the equation. So I have an excess of aqueous sodium hydroxide, so that's sodium hydroxide, to an aqueous solution containing 1.20 grams of magnesium sulfate. So it reacts with magnesium sulfate and it gives me magnesium hydroxide. What else? Mg, OH are 2 here. So I should add 2 here. So 2 Na are left and the sulfate is left. So it's going to be Na2SO4. Okay, I have this equation. I know that 1.20 grams of magnesium sulfate are present. So the first thing that you should do in this scenario is to calculate the number of moles. And how do you calculate the number of moles? You divide the mass with the MR. So I will do it on my calculator. I'll dictate it. It's 1.20, which is the mass, divided by the MR. Magnesium is 24, sulfur is 32, oxygen is 16, and there are 4 molecules, so 16 into 4. So my moles turn out to be 0.01. Okay, this is 0.01. And remember that there was an excess of sodium hydroxide. So the examiner has already given you which one is in excess, and so if this sodium hydroxide is in excess, this will be the limiting factor, magnesium sulfate. So I have 0.01 moles. This means how many moles of magnesium hydroxide will be formed? They are in 1:1. I already balanced the equation. So this is going to be 0.01 as well, because they are in 1:1. So moles of magnesium hydroxide formed at 0.01. So if the moles are 0.01, I can calculate the mass, right? If I have the MR. How will I calculate the MR? Well, that's going to be 24 plus 16 into 2 plus 2. That's 0.58. The mass is 0.58. So this was the amount or the mass of magnesium hydroxide I was expecting to be formed. But what actually formed? 0.26 grams. Okay, and if you get confused between what is the actual and what is the theoretical one, then simply remember the numerator will always be the smaller mass and the denominator will always be the bigger mass, because the percentage yield will always be less than 100%. So plug in the values. The actual was 0.26, the theoretical was 0.58, which I calculated in theory, and multiplied by 100 to make it a percentage. Let's see, what do I get? 0.26 divided by 0.58 into 100. That gives me 44.8. 44.8. So this means the answer is C. Okay, let's move on. When concentrated aqueous sodium chloride is electrolyzed using inert electrodes, which product is found at the cathode and which product is found at the anode? Basically, for electrolysis, whenever you have an aqueous solution, you have two extra ions present, one extra cation, one extra anion. If I have to write them down, the cations perhaps present are Na plus and H positive because of water, and the anion present are OH minus because of water and Cl because of the molecule itself. So the ionic compound itself, sodium chloride. So for the cations, we basically look at the reactivity series. Which one is lower in the reactivity series? The one that is lower is less reactive and is less keen on forming ions. Basically, those molecules that are at the very top of the reactivity series, they are so reactive that they prefer to form ions quickly and then remain as ions. So sodium will have less preference to form a sodium atom as compared to hydrogen, because sodium is much more reactive. It loves to exist as an ion. So at the cathode you get the cation, and at the anode you get the anion. How does that make sense? The cathode is negatively charged. I hope you know that. Cations are attracted to that. The anode is positively charged, so the anions being negative are attracted to that, because unlike charges attract. Okay, from here, which is less reactive? H positive. So from here we have the hydrogen, so C and D are wrong. What about the anode? Well, at the anode, you need to look at two factors. The first factor is I hope you guys have done this, you have learned this reactivity series for the anions, or basically not the reactivity series, the preferential discharge list. Let me write it down here. It's sulfate, then there's nitrate, chloride, bromide, iodide, and then hydroxide. The preference for discharge increases down. So sulfate and nitrate don't really get discharged. It's always it's either the halides or the oxygen because of hydroxide. So for the anion or at the anode, we look at two factors. The first one is this series, and according to that series, oxygen should be discharged. But in reality, chlorine is discharged. Why? The reason is that when you have a concentrated solution, this means there's a higher concentration of chlorine than hydroxide ions. The concentration factor dominates the preferential discharge series factor. So if chlorine is more concentrated, it will be preferentially discharged as compared to hydroxide. So remember, for the anode, you will see two factors. First of all, you will see this series, this preferential discharge list, the how keen they are to get preferentially discharged, and second thing you will see is their concentration. So, and remember, concentration factor dominates over the preferential discharge series one, and therefore the answer to this question will be A. Chlorine will be discharged. Why will chlorine be discharged? As I said, that it's a concentrated sodium chloride. There's a huge amount of chloride ions present, so they will get discharged. Which negative ions are present in aqueous copper 2 sulfate? This is kind of easy. Negative ions, There's, remember, it's aqueous. I just said this. So there's sulfate, and what is the other negative ion? That's hydroxide. This was very easy, simple, right? So the answer for 15 is C. Question number 16. The diagram shows energy profile of a chemical reaction. Which row is correct? So they're basically asking which reaction is endothermic, which reaction has a greater activation energy. I hope you know that endothermic reactions have a positive delta H, positive delta H. The exothermic reactions have a negative delta H. The arrow for delta H always goes from the reactants to the products. Just remember that. Remember that. It goes from reactants to products. So I will extend this. Delta H always goes from reactants to products. So over here the delta H is positive because the arrow goes up. I mean, you can memorize what an exothermic graph looks like, what an endothermic graph looks like, but if you ever get confused, this is the easy catch. Just remember, the delta H arrow will always go from reactants to products. From that, if the arrow points upwards, it's positive, that means it's endothermic. If it points downwards, then it's a negative, it means the reaction is exothermic. So the reaction that is endothermic is the forward reaction, because we are looking at this in this manner, like this: reactants, products. So in this manner. So the forward reaction is endothermic. So A and B are wrong. The reaction with greater activation energy. Remember that the arrow for activation energy always goes from the reactants to the very peak of the graph. So, or maybe I can draw it like that. So this is the activation energy arrow. So if these are the reactants, then the arrow is this long. If these were the reactants, because if I was looking in the opposite way, the backward reaction, then these would have been the reactants. So do you think this is taller or this one? Definitely this one. So this means the greater activation energy is for the forward reaction. So the answer is D. Okay, moving on. Table 17. Sorry. It's kind of 12:50 a.m. here, so I am not in the right state of mind. Question 17. The table shows the energy released by complete combustion of some compounds. Which compound releases the least energy when 1 gram is completely burned? I really need your attention for this specific MCQ. This is extremely important to understand. So we are talking about this 1 gram of completely burned. The least amount of energy for 1 gram when that is completely burned. A good way to do this, and remember the moles will vary this time. Why? Because moles is mass over mr. Although we're talking about 1 gram for each, the mr for each of them is different. So each of them will give a different number of moles. Okay? And remember that the delta H over here is given in kg per moles. This means that if I were to define this, it means that minus 3270 kilojoules of energy is released when 1 mole of benzene is burned. This is what it means. So for 1 mole, these are the values of energy given. I'm going to use the ratio method here. First, let's write the number of moles that we are discussing in the question. That's the mass divided by the mr. So it's 1 over 78. And for heptane, it is 1 over 100. For octane, 1 over 114. For propane, it's 1 over 44. So these are the moles for which we have to calculate the amount of energy released. Let's use the ratio method. So for benzene, we release 3270 of energy for 1 mole. So for 178 moles, how much energy is released? Cross multiply that. Let me solve it here. 1 divided by 78 into 3270, and that gives me 49. So the answer is negative 41.9 kilojoules of energy is released. For heptane, let's repeat the process. Okay, let me do this and I'll be back. Okay guys, so here I am. I've written all these values. I'll go through the method of finding these once more. So I'm using the ratio method. I first calculate the number of moles that I already have that are basically being questioned here. 1 gram. So according to 1 grams, I wrote the moles down. I have to calculate the energy release for these many moles. So what I did was I already have the amount of energy release per mole. So I used the ratio method. I wrote the energy. This is for 1 mole. So for these many moles, how many energies released? Minus 4.19, and the units would be kilojoules. For this one, what I did was 1 over 100, okay, multiplied by 4800, because for heptane there's a new value. 1 over 100 into 4800, right? And the answer was minus 48. So I repeated this process for all four, and don't get confused by these negative values. These negative values only signify that the reaction is exothermic. They have no more importance than that. Don't treat them according to mathematics. Okay, कि ये ज़्यादा छोटी value है, minus 50 is smaller than minus 41.9. No, this negative is not the mathematical negative. This negative is just signifying that the reaction is exothermic. So the answer will be A, because they were talking about the least amount of energy. So it's A. Next question. An experiment is carried out to measure the rate of reaction between magnesium and dilute hydrochloric acid under two different conditions. The mass of magnesium and the number of moles of hydrochloric acid are same. So mass of magnesium and the moles of hydrochloric acid are same. So they say, which statement could explain the difference between graph 1 and graph 2? Well, if you observe graph 1 and graph 2, you can clearly see that the total volume of gas being produced at the end of the day for each of these experiments is the same. Change the number of moles for the reactant, then you will alter the amount of product formed. How can you vary the moles? You can vary them by changing the concentration, you can vary them by changing the volume, you can vary them by changing the mass of the reactant. So over here they said the mass of magnesium is constant, so that's constant. The moles of hydrochloric acid are constant, so they have also set this constant as well. So the moles of hydrochloric acid are also constant. And this is the reason why the volume of the product being formed is not altering. But what is happening is that in graph 1, the rate seems faster because the gradient over here gives us the rate. So this is for graph 1 and then this is for graph 2. You can clearly see the gradient of graph 1 is steeper, which means the gradient for graph 1 is greater, which means the rate of the first experiment, the rate in the first experiment is greater. So what will increase the rate? We have to look for that. Graph 1 results are obtained at a high temperature. Increasing the temperature does increase the rate and it has no impact on the total volume of gas produced. So 1 is correct. Graph 1 results are obtained by using hydrochloric acid that is more concentrated. That's a tricky one. I'll come to this one later. 3. Graph 1 results are obtained using smaller pieces of magnesium. So I hope you guys know that more the surface area, the faster the rate, and it does not alter the total amount of product formed, so it's correct. 2. What for 2? Tell me. They said the moles of hydrochloric acid being formed are not changing, right? What is moles? Moles is concentration into volume. Okay. If moles are to be set constant, okay, then can I change these values in such a manner that I increase the concentration but keep the moles constant? Yes, I can. Because if I increase the concentration of hydrochloric acid, I will definitely improve the rate of the reaction. But at the same time, I will decrease the volume of hydrochloric acid. So if I increase the concentration of hydrochloric acid and decrease the volume of the solvent, which will be basically water, I will keep the moles constant. So that satisfies what the examiner said. The moles of hydrochloric acid are constant or same. So keeping the moles constant, you can still alter the concentration and volume. That's the main thing I want to convey here. The concentration can vary if the moles are even constant by decreasing the volume. And if you increase the concentration, you will increase the rate of the reaction. But because the moles at the end of the day are remaining constant, therefore the total amount of product formed will not alter. Question number 19. Hydrogen peroxide decomposes slowly at room temperature. So reaction can be catalyzed by adding manganese. Okay. and they have shown us the apparatus and all of that. They say which statement is correct when a catalyst is added to aqueous hydrogen peroxide. The catalyst increases the activation energy for the reaction. Does it? No, the catalyst decreases the activation energy. It does not increase it. Remember, it provides an alternative path with a lower activation energy. B. The catalyst is used up during the reaction. This term is actually it's very important to understand it. Used up. Used up means it was not regenerated. It was consumed and that's it. So in the reaction, it's gone. But we know that the catalyst remains unchanged even after the experiment. The reason is, and hear this carefully, catalysts do participate in the reaction. However, the catalyst is always regenerated at the end of the reaction. So catalyst does participate, but it is also regenerated. So we say the catalyst is unchanged at the end of the day or at the end of the experiment. So saying the catalyst is used up is wrong because it isn't used up. It is regenerated. See, the gas syringe fills up more quickly when the catalyst is added. What they are, in other words, trying to say is that the rate improves because when the rate improves, the gas fills up more quickly with the product. So yep, that's true because the catalyst does increase the rate of the reaction. The total amount of oxygen produced increases when the catalyst is added. Nope. Remember, as I said, the amount of product can only be changed if you change the number of moles of the reactant, and that can only happen if you change the concentration, the moles, or the volume in such a manner that they increase the moles. Question number 20. Reduction can be defined in terms of the gain or loss of oxygen or of hydrogen or of electrons. Which row correctly describes all three definitions of reduction? The way that I like to do this is, remember this term, her. Yeah, it's her. Her is basically, this right here is hydrogen, this right here is electrons, and this right here is reduction. What her means is that whenever there will be a gain of hydrogen and electron, there will be reduction. So remember her. Okay, remember her, please. So definition of reduction is when there's a gain of hydrogen or electrons. So where do I see hydrogen or electrons? So gain. Well, the only place it says gain is oxygen loss, and that's kind of obvious because when oxygen is gained, that's oxidation. For that, you can actually remember OO, which is kind of pathetic. For oxidation, it's weird. OO, like, okay. But yeah, it's oxygen and resulting in oxidation, and her is hydrogen and electrons resulting in reduction. So I hope you found this session interesting. I was kind of because it's late at night, I might not have been as good at teaching this, but I still hope that you found it helpful. For now, ijazat dijiye, and the next time I will meet you guys with much more enthusiasm, many more questions, and yep, see you till then.